I'm Ennemcien. Welcome to Q-Master. First problem. In a two-stage heat engine, a quantity of heat Q1 is absorbed at a temperature T1, work W1 is done, and a quantity of heat Q2 is expelled at a lower temperature T2 by the first stage. The second stage absorbs the heat expelled by the first, does work W2 and expels heat Q3 at lower temperature T3. Efficiency of the first stage is eta 1 and that of the second stage is eta 2. What is the efficiency of the combined engine eta? That is the question. See the block diagram. This is the first stage of the engine. In this stage, the engine absorbs Q1 amount of heat from the high temperature T1, rejects or expels heat Q2 to a lower temperature T2, and it does a work W1 equals Q1 minus Q2, we know that. Then the second engine, the source of the second engine is the sink of the first, so that it absorbs heat rejected by the first stage. That is, it absorbs Q2 unit of heat from T2 temperature and expels heat Q3 at a lower temperature T3. Then it does work done by the second stage is W2 equals Q2 minus Q3. Then the total work done by the combined engine, W must be equal to W1 plus W2. Put it as equation number 1. Now, efficiency of the first stage, eta 1 equals work output by heat absorbed, W1 by Q1. Efficiency of the second stage, eta 2 equals W2 by heat absorbed by the second stage is Q2. So, W2 by Q2. And efficiency of the combined engine. For the combined engine, this is the source and this is the sink. So, and heat absorbed by the combined engine. When you take the combined engine, heat absorbed is Q1 and work output is W. So, efficiency of the combined engine eta must be equal to W by Q1. From these expressions, you can find out W1, W2 and W and substitute in this equation. So, we get W is eta into Q1. Eta into Q1 equals W1 is eta 1 Q1 plus W2 is eta 2 into Q3. Okay. So now you divide the whole equation by, this is Q2. I'm sorry, W2. In the place of W2 is eta 2 into Q2. You substitute these values in first equation, you get like this. Eta into Q1 for W equals eta 1 Q1 plus eta 2 Q2. You divide the whole equation by Q1. Then you get eta equals eta 1 plus eta 2 into Q2 by Q1. That is equation number 2. But we know that for every heat engine, for all heat engines, there is a general expression for efficiency, that is eta. Now, for the first, eta equals heat rejected by heat absorbed, 1 minus 1 minus Q2 by Q1. That is the expression for eta for all engines, general formula. So we have eta 1 equals 1 minus Q2 by Q1. So Q2 by Q1 equals 1 minus eta 1. You can put this value in equation 2. Here it is Q2 by Q1. So you get eta equals eta 1 plus eta 2 into Q2 by Q1 is 1 minus eta 1. Simplify this. You get eta equals eta 1 plus eta 2 minus eta 1, eta 2. This is the efficiency of the combined engine. That's all. Another question. Two identical pieces of ice fly toward each other with equal speed and are converted fully into 0 degree Celsius water upon impact. If the latent heat of fusion of ice is 335 into 10 raised to 3 joule per kilogram, find the initial velocity of each. That is the question. Two ice blocks fly toward each other and they hit and then they melt, where kinetic energy is converted into heat energy. So what must be done? Now we have to find out the initial velocity of each block. That is a question. Our kinetic energy of one block is half mv square. Since the blocks are identical, mass is the same, velocity is said to be the same. So total kinetic energy of the two blocks must be 2 into half mv square. That must be equal to heat that melts the ice. Latent heat of fusion is the amount of heat to melt 1 kilogram of the substance. So that LF is the latent heat of fusion. Therefore, to melt m kilogram of a solid into liquid, at its melting point is m into LF. So this total kinetic energy must be converted into heat energy m into LF. So you can write 2 into half mv square equals m into 2 blocks are there. So 2m into LF, from which you can cancel the common terms. Then you get V velocity, V equals square root of 2 into LF. LF is latent heat of fusion of ice. That is given here. So root of 2 into LF is given to be 335 into 10 raised to 3. This is 670 in 670. Okay, 670 into 10 raised to 3, or root of 67 into 10 raised to 4. Root of 10 raised to 4 is 10 raised to 2. Root of 67, 8 square is 64. The rest is 3. So 3 by 8. So this is nearly 8.18. We can find out the value by mental calculation. If the exam is entrance exam, by looking at the choices, you can find out the answer with the help of your mental calculations. So this is nearly 8.18 into 10 raised to 2, or 818 meter per second. That is the initial speed of each block.